Myself K. Lakshmi, Assistant Professor of Narasimha Reddy Engineering College. So today I am going to teach you multistage amplifiers of first unit. Let us see introduction of multistage amplifiers. To have faithful amplification, the amplifier should have desired voltage gain, current gain, and it should match its input impedance with the source and output impedance with the load. So why do we need cascading? When the amplification of a single stage amplifier is not sufficient, or when the input or output impedance is not of the correct magnitude for a particular application, two or more amplifier stages are connected in cascade. Such amplifier with two or more stages is also known as multistage amplifier. If we see the block diagram of two-stage cascaded amplifier, so it has two stages. Okay, so any transistor consists of more than one stage is nothing but cascaded amplifier, or we can say multi-stage amplifier. Okay, so externally source and load are connected as shown in the figure. For the stage 1, input voltage is nothing but V in, output voltage is nothing but VOT. Okay, similarly for the second stage VI2, and for the second stage output voltage is VO2. For first stage, that is VI1 and VO1. Gain of two-stage cascade amplifier. Okay, let the first stage gain be G1, second stage gain be G2. Okay, similarly, what is the power of the input stage? That is nothing but P1. Next, output of stage 1 power is nothing but input of the second stage, that is denoted by P2, and the output of the second stage, or I can say overall stage, is nothing but P3. So overall gain equal to, that is gain of first stage is denoted by G1, which is nothing but P2 by P1. G2 is nothing but P3 by P2. Overall gain is nothing but, that is output voltage to the input voltage of the multi-stage amplifier, P3 divided by P1. So it can be written as P2 by P1 into P3 by P2. So P2 by P1 we know it as G1, P3 by P2 we know it as G2. So G equal to G1 into G2. So decibel voltage gain. So when stages are cascaded, then the gains will be multiplied, whereas in decibels gains will be added as shown in figure C. A equal to A1 into A2, and in decibels A1 equal to, that is A1 plus A1 prime plus A2 prime. Okay, why do we represent gain in decibels? Actually, there is some reason, that is, it is found that convenient to compare two powers on a logarithmic scale rather than on a linear scale. So the unit of this logarithmic scale is called decibel. Decibel means power ratio. So that is the number n decibels by which a power P2 exceeds the power P1 is defined by n equal to log P2 by P1 to the base 10. Okay. So actually here P2 represents the output power of an amplifier, P1 represents the input power of an amplifier. So P1 can be written as Vi square by Ri, P2 can be written as V0 square by R0, where Ri and R0 are input and output resistances of an amplifier. Suppose if Ri equal to R0, then N equal to, so you are going to get 10 log V0 by R0, V0 square by R0 divided by Vi square by Ri. If Ri equal to R0, then N equal to 10 log V0 by Vi whole square. So that is nothing but 20 log V0 by Vi to the base 10. That means gain in multistage amplifier in dB will be added. Advantages of representation of gain in decibels. So why do we represent gain in decibels? Okay, logarithmic scale is preferred over linear scale to represent voltage and power gains because of the following reasons. Using logarithms, multiplication is changing into addition, small as well as large figures of linear scale changing into smaller figures, For example, if the gain is 1 lakh, it can be represented in decibel as 20 log 10 to the power of 5 to the base 10, which is equal to 100 dB. That means in linear scale its value is representing 1 lakh, means in decibel, in logarithmic scale its value is converting into a small value, that is 100 dB. Actually, the output of amplifier will feed to loudspeaker to produce sound which can be heard by human ear. Ear responds to the sound intensities on a logarithmic scale than linear scale. So therefore use of dB is very important for representation of amplifier gains. So that is why always gain should be represented in dB. So for a two-stage RC coupled CE cascade amplifier. So when two CE amplifiers are cascaded, then it is known as CE cascade amplifier. So if we see in, like in multi-stage amplifiers, so we have to do the analysis of two-stage amplifiers. Already in the previous topic, so I told you how to analyze any transistor amplifier circuit by following certain steps. They are nothing but first draw the actual circuit diagram, then short the coupling capacitors and emitter bypass capacitor, next short the VCC, that is make it ground, next locate base, emitter and collector on the circuit diagram and start these points as start of the experiment. Next replace transistor by its H parameter model. Same steps should be followed even for the multi-stage amplifiers. We should always start analysis with the second stage, because the load of first stage is nothing but input resistance of the second stage, and the source of second stage is nothing but output resistance of the first stage. So because of this we should always do the analysis with the second stages. So we have different types of combinations, that is analysis of a two-stage RC coupled CE amplifier, next two-stage like CC amplifier, cascade amplifier. It is the combination of CE and CB amplifiers. Next Darlington pair, just now I have explained you two stages of CC is nothing but Darlington pair. So actually in a single stage CC amplifier we have seen that the input impedance of CC amplifier is reduced by using biasing resistors. Okay, therefore in order to improve this input impedance we have two techniques known as direct coupling and bootstrap. So direct coupling is nothing but direct connection of two CC amplifiers is known as direct coupling. So whereas bootstrap is another technique to improve the input impedance of single stage CC amplifier.